Welcome friends to Quick Algebra Problem Solving. This is Atanu Chaudhary of SureSolve. Today in this first part, we'll solve question 1 to question 5 of SSC CGL Solution Set 57 on Algebra 13 from SureSolve.com. Let's solve the first problem. Have a look at the problem and try to find a way to the solution. The simple integer choice values tell you that the three algebraic fraction terms can be combined to a simple bed. But how to combine the fraction terms? The key lies in making the denominators equal or as similar as possible. You look at the given expression AB plus BC plus C equal to 0 and the first denominator A square minus BC together and immediately discover the way out. You decide to use similarity increase technique and replace minus BC with AB plus CA to get the first denominator as A square plus AB plus CA equal to A multiplied by A plus B plus C. In the same way, minus CA and minus AB in second and third denominator will be replaced by AB plus BC and BC plus CA respectively to simplify the denominators to B multiplied by A plus B plus C and C multiplied by A plus B plus C. The problem is practically solved at this stage. 1 by A plus B plus C will be factored out. In the other factor, sum of 1 by A, 1 by B and 1 by C will have AB plus BC plus C equal to 0 in the numerator. Final result will then be 0. The deductive steps are 1 by A multiplied by A plus B plus C plus 1 by B multiplied by A plus B plus C plus 1 by C multiplied by A plus B plus C. Equal to 1 by A plus B plus C multiplied by 1 by A plus 1 by B plus 1 by C. Equal to AB plus BC plus CA divided by A plus B plus C multiplied by ABC equal to 0. Answer is option B, 0. You can solve the problem easily in mind, but you have to use the similarity increase technique and discover the pattern for the crucial substitution. Let's solve the next problem. Read the problem carefully and visualize the line graph on the XY coordinate system. What do you find? With y equal to 0, x equal to 8. So x-axis intercept of the line AB is y equal to 8 cm. And with x equal to 0, y equal to 6. So y-axis intercept of the line AB is OB equal to 6 cm. By the given coordinates of the points P and Q, which are the points of intersections of the line PQ with x-axis and y-axis, OP equal to 2 while y equal to 8, which is 4 times of OP, and OQ equal to 3 by 2 while OB equal to 6, again 4 times of OQ. Let's see the diagram for better understanding. In the two triangles OAB and OPQ, the ratios of corresponding sides OP by OA equal to OQ by OB equal to 1 by 4. And included angle AOB, the right angle at the origin O, is also same. By side angle side criterion of similarity of two triangles, then the two triangles OAB and OPQ will be similar. The ratio of all pairs of corresponding sides will be equal. So PQ by AB equal to OP by OA equal to OQ by OB equal to 1 by 4. Or PQ equal to 10 by 4 equal to 2.5 cm. Answer is option A, 2.5 cm. With visualization, you may solve this problem easily in mind without drawing the diagram. Let's solve the third problem. Analyze the problem and think how you would solve it. The two-factor expansion of x cube minus 1 by x cube is x cube minus 1 by x cube equal to x minus 1 by x multiplied by x square plus 1 by x square. So from x to the power 4 plus 1 by x to the power 4, you have to first evaluate x square plus 1 by x square and then x minus 1 by x. First to evaluate x square plus 1 by x square. X square plus 1 by x square whole square equal to x to the power 4 plus 1 by x to the power 4 plus 2 equal to 121. Or x square plus 1 by x square equal to 11. Being sum of squares, it has to be positive. Next evaluate x minus 1 by x. X minus 1 by x whole square equal to x square plus 1 by x square minus 2 equal to 9. Or x minus 1 by x equal to 3. As positive value of x cube minus 1 by x cube is wanted in the question, we will ignore negative value of x minus 1 by x. Finally, x cube minus 1 by x cube equal to x minus 1 by x multiplied by x square plus 1 by x square equal to 3 multiplied by 11 plus 1 equal to 36. Answer is option B, 36. Can easily be solved in mind. Calculations are simple and no special patterns are to be discovered. Let's solve the fourth problem. Analyze the problem and try to find out how you would solve it. The problem is to be solved by applying the principle of least value of sum of reciprocals. For three variables a, b and c, by this principle, if a plus b plus c equal to 1, the least value of sum of the reciprocals will occur when variable sum of unity is equally shared between the three variables. That is, a equal to b equal to c equal to 1 by 3. The least value of sum of reciprocals of a, b and c will then be 1 by a plus 1 by b plus 1 by c equal to 3 plus 3 plus 3 equal to 9. Answer is option C, 9. For two variables x and y, we will show you a simple proof of this principle using mathematical reasoning. We have to prove if x plus y equal to 1, where x and y are two positive real numbers, sum of the reciprocals 1 by x plus 1 by y will have the least value of 4, when the value of 1 is shared equally between x and y as 1 by 2 each. That is, x equal to y equal to 1 by 2. When x plus y equal to 1, let's assume variable sum of unity is shared equally between x and y as x equal to y equal to 1 by 2. So that 1 by x plus 1 by y equal to 2 plus 2 equal to 4. To show now, for any other combination of values of x and y, the sum of the reciprocals will be greater than 4. Reduce x by an arbitrary real positive amount of p, and to compensate for satisfying x plus y equal to 1, increase y by the same amount of p. The changed values of x and y will be x equal to 1 by 2 minus p and y equal to 1 by 2 plus p. So the sum of reciprocals will be 1 by 1 by 2 minus p plus 1 by 2 plus p equal to 1 by 2 whole square minus p square. p being any positive real number, p square is positive, and new denominator 1 by 2 whole square minus p square is less than 1 by 2 whole square. Or the new sum of reciprocals 1 by 1 by 2 whole square minus p square is greater than 1 by 1 by 2 whole square, which is 1 by 1 by 4 equal to 4. So with p as an arbitrary positive real number, this process effectively shows for any combination of values of x and y other than 1 by 2h, the sum of reciprocals would be greater than 4. Only when the variable sum of a unit is equally shared between the two variables x and y as 1 by 2h, the sum of the reciprocals will be the least and the least value will be 4. The concept that equal shared value results in least sum of reciprocals can be extended to 3 or more number of positive real variables. If you know the principle, you can solve this problem in no time. Let's solve now the last problem. Read the question carefully and try to find a way to proceed. It's not an easy problem. Identify two key patterns that are related to each other. First, each of the denominators conforms to missing element pattern with A, B and C missing from the first, second and the third to make all of them equal to A plus B plus C. And second, the RHS is 4 times of A plus B plus C. Based on these key observations, you decide to bring in dummy variable p equal to A plus B plus C to reduce the total number of terms by 2 and simplify the equation to some extent. You have used here the powerful term reduction technique. Substitute p equal to A plus B plus C and the target expression is simplified to x minus a square divided by p minus a plus x minus b square divided by p minus b plus x minus c square divided by p minus c equal to 4p. A very favorable change has also happened to each pair of denominator and numerator. Apart from x and p, the two other variables became same. A for the first pair of numerator and denominator, b for the second, and c for the third. You have not been able to equalize the denominators, but now there is a distinct possibility of equalizing the numerators instead. You now discover the key pattern that if you subtract p plus a from the first term, p plus b from the second, and p plus c from the third, all numerators will become equal to x minus p square. You look at the RHS value of 4p and easily find that you can express it as 4p equal to 3p plus a plus b plus c equal to p plus a plus p plus b plus p plus c. So as expected, you have those three sums p plus a, p plus b and p plus c on the RHS waiting to be transferred to the LHS and allotted to the first, second and the third terms, and at the same time reducing the RHS of equality to 0. Common factor x minus p square is then 0 and x equal to p square equal to a plus b plus c whole square. Answer is option D, a plus b plus c whole square. Let's show you the last step deductions. X minus a square divided by p minus a minus p plus a plus x minus b square divided by p minus b minus p plus b plus x minus c square divided by p minus c minus p plus c equal to 0. Or x minus a square minus in the brackets p square minus a square divided by p minus a plus x minus b square minus p square minus b square in the brackets divided by p minus b plus x minus c square minus in the brackets p square minus c square divided by p minus c equal to 0. Or x minus p square multiplied by 1 by b plus c plus 1 by c plus a plus 1 by a plus b equal to 0. So x minus p square equal to 0, or x equal to p square. This is not an easy problem to solve at all, but one can still solve it in mind by reducing the complexity of the expression by identifying a same element pattern and choosing dummy variable p to substitute for a plus b plus c. That also conforms to term reduction technique. This single step has also increased the similarity between the numerator and denominator of each term. At the second step, you could now easily discover the need of subtracting p plus a, p plus b, and p plus c from the first, second, and the third terms to make the numerators equal. That is, application of both numerator equalization technique and similarity increase technique. It is natural that in the RHS you would find exactly what you needed. To read the detailed solutions, refer to the corresponding article in our website shivsolve.com. The link is given in the description of this video. Thanks for watching.